All right, thanks everyone for tuning in. Welcome to Extending on Reth. I'm libEVM or library, Ethereum virtual machine, and I'm currently with Mantle. So yeah, background, I'm at libEVM on Twitter, currently a DevRel on mantle.xyz. I also run a MEV dashboard called libmev.com, and we also run this is separate to Mantle, by the way, this is my own thing. We also run an Ethereum block builder called Penguin Build, and we're currently about 2% of all block space. So anyway, extending on Reth, why? Why do you care about extending on an execution client? Well, one, you're Rust curious, you're data curious, or you're curious about the low-level details of Ethereum, like how do you sync up with peers, or how do you validate a transaction, how do you calculate the Merkle trie, blah, 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 blah. Or you're just a JoJo's fanboy. So any one of the above can be valid. And yes, what is Reth? Reth is a Ethereum execution client written in Rust, hence Reth, Rust Ethereum. The whole point of Reth is that it's designed to be extendable. So the components are modular. It's intended to be used as a library or as a standalone node where you can extend upon it. This is very different from the design choices of Geth, where it was designed to be very monolithic. And building on top of Geth is very painful because that means that every time you want to merge any upstream changes, you have to do like a rebase. But with Reth, you can use S because you can use it as a library. There's no need to pull in the upstream changes. You just bump the version up or the Git hash, depending on how you handle your application. And I know what we're all thinking, just show me the code. I don't really care, blah, 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 blah. So I will. So one example is the custom RPC method. So say you're a developer and you really, really, really want to extend, and let's say there isn't an RPC call that allows you to do what you want to do. You can easily extend on Reth and build your own custom RPC method. For example, if you like ETH call, but you want ETH underscore call to do something more, you can. And with a few lines of code, you can do that. So in this example, you have you define the trait of your custom API. In this case, my trait name is called custom ETH namespace extension API. Very verbose, I understand, but you can always shorten it to whatever suits your purpose. And in this case, I want to add a new function called block gas, which gives me the gas used in a block. So I don't want to query the block, get a bunch of useless data, and then find out the gas used from there. I just want to be able to get the gas used from the block in one transaction. So I create a custom struct called custom ETH namespace extension, which takes in a provider, and then I write the implementation. So custom ETH namespace extension API server, and all I do here is I get the block and I return the block.gas used. And from there, I'm able to extend on the node and create my own custom namespace. In this case, it's called my namespace, where I can get the block gas. And to add it into, and to insert it into the main function, you just need a few lines of code, all of which are in the examples. So you just define your server in this case. You create your RPC server. So this is all in the Reth examples. And then you create your custom RPC, custom ETH namespace, and all you do is call custom RPC dot into RPC, and boom, you have a whole new namespace and RPC method. And to query it, this is all you do. It's a standard RPC method, so you can do a post request, and you can just specify the method name. In this case, it's my namespace underscore block gas, and you can supply the params. It's that easy. And I know you might ask, why do I care about extending my own custom namespace? This block gas method seems very, very useless and very pointless. But in the event that you're trying to do something non-standard, for example, extend a node where it emits shadow logs, you can do that quite easily. Now, Aragon has this feature called overlay underscore get logs, but it's very non-standard and it's not implemented in a lot of clients. But you, as a budding Rust fanboy or Ethereum lover, if you will, you can easily extend Reth and add in this custom method, overlay underscore get logs, without diving deep into the Reth code base, but rather using it as a library. In addition to that, if you would like to add in your own RPC method while maintaining compatibility with the upstream, you do not need to wait. So you do not need to wait for years for your PR to be merged into the main. For example, this is a request for an RPC method called ETH underscore batch call. This was proposed and in 2022 September, where there was, I think Sina wanted to merge this into Ethereum main for various reasons. And till date, it still remains unmerged. Very epic. But yes, anyway, so that's one of the few reasons on why you might be interested in Reth. So again, something emphasized is that Reth is used as a library. You're not forking it and extending on it. It is used as a library. You extend and go. And all you have to do is to merge upstream changes is to change your version up. You bump the version up and then you fix all the bugs that Reth previously had, and you're good to go, no fuss. All right, showcase 2, mempool analysis. So hypothetically, if you're running some sort of mempool analysis tool like Flashbots is doing, and you would like private or public, in this case, on Etherscan, you can actually see them quite clearly. If it says transactions mined within X amount of seconds, that's usually a public transaction. But if it doesn't show the timestamp, it's usually a private transaction. But if you would like to do some kind of analysis to kind of log the data, like these transactions are private or public into a database, you can actually do it in a few lines of code. And keep in mind, this is the main function, so we're using Reth as a library here. So we're not going into the code base and then injecting stuff in random places. We're just calling it like a library. So all we do is call Reth CLI pass, so this passes your CLI parameters, which spawns a builder, which is the node builder, and some arguments. You can then get the pending transaction stream from the node, and then you can execute a new task, asynchronous task, and you can do whatever you want in that task. In this case, I'm listening for pending transactions, and you can do any kinds of whatever kind of analytics you like. So you could dump it to a database. You could analyze where the transactions originate from. Is it from these peers, and what IPs are these peers? Are they from APAC region? Are they from the US region? And you could probably do some further analysis on it if you're curious. And this is all done within, I think, 30 lines of code, and to extend upon it, to get the pending mempool stream and perform some analysis. So within a few lines of code, you've essentially made a public good and a transaction labeler. Very, very nice. One use case is the Flashbots mempool dumpster, where it dumps out like a Parquet database of whether or not the transactions are public or private. This is used in a lot of Dune Analytics dashboards to kind of determine MEV data flow in terms of like private/public transactions, the share, the percentage of private/public transactions, and how much do they contribute to block builders winning the block. If that's partially why I'm curious about this. And showcase 3 would be a standalone P2P node. And so when you have the Ethereum node, you have the peer-to-peer protocol. I don't actually remember what it's called, but you communicate with other ETH clients through this protocol. And you can also do further analysis on this. You can identify like which peers are sending you more transactions, and what kind of clients each peers are running. So for example, in this case, I'm skipping ahead, but you can do like a P2P network analysis for like ethernodes.org. You can see, okay, what the majority of the nodes are running. Is it Geth? Is it Nethermind? Is it Besu? Is it Aragon? And you don't need to rely on these third parties to verify the data. You can very easily run your own node with a few lines of code to verify the data yourself. Remember, it's verify, not trust, not the other way around. But yeah, with a very, very, very minor amount of work, you're able to kind of spawn a new node or a standalone node component to kind of communicate with the P2P network, which is very painful, and do analysis on it. There's also a lot more examples. Like, we can actually check it out on the official Reth examples. You have, if everyone can see, you can run your own. You can run your own custom EVM if you want to add in your own precompile, for example. You can run your own payload builder if you think the pre-existing block building algorithm is too weak. You can directly access the database of which to do further analysis on the transaction data, mine transaction data in this case. Obviously, so Reth is a archival node by default as well. So you can trace back to the beginning of the genesis. And with database access, you're not querying data through some kind of WebSocket or HTTP port. So the data you get there is it's very quick to do analysis on there. You can add custom hooks, and I think the latest thing in the Reth land is XX, or execution extensions. If anyone's following along, I do not know what it means. They coined the term last week, and I just saw this tweet and decided to put it in. But XX is a thing now, so you heard it from here first, folks. Yes, hopefully I have pilled most of you enough to start looking into Reth. It is a very, very nice learning tool, as well as a practical tool if you're curious on Ethereum execution client development. It's very easy to get started and very hard to break things. And also, it also helps you learn a bit of Rust if you're curious. And I think that's kind of my time. So thank you guys for listening. If you guys have any questions, happy to answer them.